Hello and welcome. This tutorial is about how to make a camera that is dynamically but following the player depending on the player's speed, no matter how fast the player will go. So you can see here I got my game project, here's my player, and if I move around nothing is happening. So let's get to the camera. And we're gonna need a new script. Create a C# script. Call it camera. Open it. There we go. There is our camera. So first of all, I'm gonna show you what we're gonna use. There are two Unity functions we're gonna use for this. One is mathf.smoothDamp, and it is described as gradually changes a value towards a desired goal over time, and the value is moved by some spring damper-like function which will never overshoot. So we're gonna use this for the X movement of the camera because we want a direct feel for the X movement. And since we want to have a more smooth and more accelerating over time behavior for the Y movement, we're going to use the vector 3.smoothDamp, which I will show you in a second. So let's get started with the X-axis movement. And we're gonna need some variables for this, and we're gonna use first a private vector2 that represents our velocity. So I'm gonna call it velocity for X. Then we're going to use a serialize field, and that's for showing a private variable in the editor. Private float smooth time X, and this value will define how fast the camera will move. And then we need a private player platform controller. So this is the player platform controller is the script where I handle my player movement, input, and everything, and we're gonna use it as a reference for the actual player position. So on void start, we need to define the reference for the player platform controller, and I have a very nice script, a game asset script, where I hold all the references that I have in my game. You can see it here. I got all the important scripts in there, and I store the references on enable. I will search for the objects, and then I have all the references here, and I will use that. So player platform controller is game assets.instance player platform controller. So we're gonna use void fixed update. Well, let me change that. And in fixed update, we're gonna set another float pos x is equals to, and here we go with the mathf dot smooth damp. So and here you can see the definition for the mathf.smoothDamp. It's getting a float of the current object, a float for the target object, and referencing the current velocity, and a float smooth time, which is the value who defines how fast the object will move. So we're going to use for the current value, we're going to use transform.position.x, which is the actual position of the camera. And for the target, we're going to use player platform controller.transform.position.x. We're going to reference the velocity. This is our velocity for x. And then we got the smooth time x for smooth time x.x. Is it like that? No, it is smooth time x, and we're missing something here. So since we're only handling the x position, I have to grab the x value of this vector2 variable. So we got our pos x, and now we have to do something with it. So we're gonna say transform.position equals, that's the transform position of the camera, and it is equals to new vector3, and this vector is going to hold our pos x value for the position on the x-axis, and then we're gonna use transform.position.y for the y value, and transform.position.z for the z value. So we're using this one, and this one we're just using the values of the camera, and so we're not changing them, but with the pos x we're going to change the x-axis position of the camera. So let's test. Let's get over here, and what we need to do, we need to drag the camera script over here, and we have to define the smooth time value, which is the value who defines how fast the camera will move, and I'm going to set it to 0.15. Let's hit play, and you see the camera snaps to the player, and we move, and you see we have this nice smooth movement behavior, which is pretty direct and feels all good. So, and here comes the point why we will not use this method for the y movement, which is this with is the jumping. You see, this movement is very direct, and we don't want to have this on jumping. If you jump, we want a very smooth movement, which will speed up rapidly if we jump down from a certain height. If you jump down from a very high ground to a low ground, it has to speed up, and that's not possible with this method. So I'm going to show you what we are going to use instead. Let's jump back into the script, and we need to define a few more variables. So first of all, we're gonna have another velocity value. So private vector3 in this case, velocity for y, and then we're gonna define another variable with a serialize field, private float smooth time y, so that we can handle the speed separated from the speed that is used for the x movement. We can have our own speed for the y movement. Okay, so then we need two more things. Since we want to have the option to define a certain height the player has to jump before the camera starts moving. In order to calculate that, we need two more things. We need one private float for the height difference. And that's going to be the height difference between the player and the camera. And then marked as serialized fields, we need a private float, and I'm gonna name it y move trigger distance. Okay, what are we going to do with that? First, we have to calculate the height difference between the camera and the player. So, height difference is player platformer controller dot transform dot position dot y minus the transform dot position dot y, which is this is the y value of the player, and this is the y value of the camera. So we're calculating this height difference every frame. So now we need to handle the velocity for y value. And since we want to have it like be more smooth but accelerate over time if the player gets really fast, we need to do a calculation on time.smooth delta time. So velocity for y is equals to velocity for y times time dot smooth delta time. And smooth delta time is the smooth out time dot delta time. It's like time dot delta time but smoothed. Alright. So now let's move on to the y-axis movement. And we're gonna have to have some if statements. So since we want to only move the camera in the y position when it gets beyond the y move trigger distance, we have to say if height difference is, let's say, bigger than a y move trigger distance, and if it is so, then we have to calculate our transform that position will be equals to, and here we go, vector3 dot smooth damp, and here you can see it is asking for the vector3 component of the current object, which is the camera. So we're going to use transform.position, and then it needs the vector3 of the target, and here we say new vector3 and there we take the transform.position .x, which is the x position of the camera, and we take the x position of the camera because we don't want to change it. We only want to change the y position. So for the y position, we're gonna take player platformer controller dot transform dot position dot y, and here we have to do a calculation. We're gonna subtract it from the y move trigger distance, and then we're gonna hold here transform dot position dot set for the set value. All right, next thing, this vector3.smoothDamp method is going to ask for our reference the current velocity, and as you remember, we got the velocity for y up there, so we're going to use it, velocity.y, and then it's also asking for the smooth time, and we got our smooth time for y. Okay, so this is our very long statement for the case if the height difference is bigger than the y move trigger distance, which means the player is jumping upwards. But the player will not only jump upwards, he will also jump downwards. And I will show you in a second how we're going to do that. But first, to keep it simple, I want to implement what is happening if the player is not getting beyond this y move trigger distance. And so I'm going to say else. Transform.position equals to vector3.smoothDamp. Here we go. Transform.position .x. And since in this case we're not going to adjust the y value, we're going to say new vector 3 transform.position.x. That's similar to the method before. And then we're gonna use transform.position, oh my god, position.y, which is the camera's y position, because we don't want to change it, and transform.position.set. And then referencing our velocity for y and also the smooth time for y. Oh, I got a little mistake here. It's a vector 3, so it's just transform that position. All right, so let's test. Let's hit play. So, and the smooth time.y, let's see how much we're gonna say. Something like that. And we have to define the y movement trigger distance, and I will set it to 1. Alright. Let me tweak something. Enable the double jump. So, you see our x-axis movement is working, and now I'm jumping on the y-axis, and you can see as I'm jumping that we are moving on the y-axis, but very smooth. And it's only moving upwards but not downwards. You can see it here because we didn't implement the downwards direction, which we will do in a few seconds. So let's get back to the script, and we're gonna add some gonna get here and say else if. And we're gonna say here, since we want to address the down movement, we're gonna say if height difference is smaller than the negative value of a y move trigger distance. So, and for this we can pretty much copy the same thing we did up here. Gonna paste it in there. But instead of subtracting the player platformer controller transform position dot y with the move trigger distance, we're not gonna subtract it, but we're gonna say plus the y move trigger distance. So let's save. Get back into the Unity. Let's test. Gonna enable the double jump. And you see that the player is moving now instantly, and I show you why. That's because we didn't define these values. You have to do this while the editor is not playing. So change that value, and you can see you can do little jumps, nothing's happening, camera's not moving. And you do bigger jumps like that, and the camera starts moving upwards and also moving downwards. And you see it's a very tiny smooth movement, but I'm gonna show you what's happening. If you get further up there, you can see that now there is a faster movement on the y-axis. And if I jump down from high up there, you can see it is accelerating but not catching up with the player. So I'm gonna change this value to 0.1. And you can see we get a little bit more movement, but it's still very smooth and tiny. Let's get up there. Want to jump down from here, and we jump down, and you see the camera is almost catching up. So let me change the value to 0.07. Try again. So jump down, and now you see it is catching up with the player. And if we are only doing some small jumps, it's not moving at all. And if you're jumping and not moving too far, it's a tiny move. And if you jump down from a certain height, then the movement is faster. And there you are. You have your camera follow script, which is a very direct on the x-axis and which is very smooth on the y-axis, where you can define a certain trigger distance value which needs to be which the player have to move over before the camera starts moving. and you have these tiny and slow movements if the distance between the player and the camera is not too much, and if the player drops down from a high level and he's accelerating, then the camera catches up with him. So, thank you very much for watching. If you found this tutorial helpful, then consider subscribing, and you will see more videos on this channel related to scripting tutorials. Thank you very much. Have a nice day. I see you in the next one.